Adding and subtracting rational expressions. To add and subtract rational expressions, you need a common denominator. Let's review the steps to get a common denominator. When we have numbers, we just need to find the least common multiple. Common multiples of 8 and 12. The least is what you'd want. 8, 16, 24, keep adding 8, 32, 40. Multiples of 12 are 12, 24, 36, 48. The least common multiple is 24. Think of it this way, though. The least common multiple is the number, the smallest number, that 8 and 12 divide into evenly. 24 is that number. Then you ask yourself, what do I multiply 8 by to make it 24? That would be 3. Now you can't just multiply a fraction by 3. You're multiplying by 3 over 3, which is really 1. And 1 times 1/8 will still be 1/8, but now it will have a denominator of 24. What do I multiply 12 by to make it 24? That would be 2. So I'm going to multiply by 2 over 2, and the 12 will become 24. Now I've got my common denominator. It'll be 3 over 24. Notice this 3 times 1. And 2 times 1 will be 2 over 24. Don't forget you keep your denominator of 24. And the answer then would be 5 over 24. And you'd always look to see if that's simplified. It does not. When I have rational expressions, polynomials, in this case like x plus 3 and x plus 5, I need my least common multiple also. A little less obvious what it is though. But think of it this way. What you want is to do the least you can do and make the denominators the same. Remember that you're always multiplying by 1 because you're not going to change the value of that denominator. If x plus 3 is in your denominator, then x plus 3 is part of your common denominator. You can't turn x plus 3 into x plus 5. There's no way to do that. If x plus 5 is part of your denominator, then x plus 5 will be part of your common denominator. So again, what's the least you can do and make those denominators the same? This side will need an x plus 5. Notice I'm multiplying by 1. Anything divided by itself is 1. And this side will need an x plus 3. And that's the least I can do and make those denominators the same. Do not remultiply your common denominators. Common denominator is x plus 3 times x plus 5. So here, I'll take 1 times x plus 5, that's x plus 5. And here, I'll take 1 times x plus 3, and that'll be x plus 3. This ends up being 2x plus 8 over x plus 3 times x plus 5. And that would be your answer. However, just like I said right here, you need to make sure this doesn't simplify. Look at the top and notice it has a GCF of 2. Now, you don't need to pull that 2 out because it's not going to help you, but let's point out that this is 2 times x plus 4. And if I'd had an x plus 4 below, I don't, I could have canceled that x plus 4, understanding that I've still got to keep in mind my restrictions. Nothing cancels. This is the actual answer that I would want then. You do not need to factor unless it allows you to cancel. Take a look at these examples. In this first one, they already have a common denominator of x minus 5. 3 plus 4 is 7. That's it. 7 over x minus 5. In the second one, you might look at this and think, well, 3 minus x and x minus 3 are different. Well, you'd be correct. They are different. However, they're actually opposites. See how the 3 is positive and the 3 is negative? And the x is negative and the x is positive. 3 minus x and x minus 3 are exactly the opposite of each other, meaning they're only different by a negative. So what you can do is pull a negative out of one of those denominators. Now, I kind of like x minus 3 better than 3 minus x. It doesn't matter, though. Either way would be correct. I'm going to put parentheses around this, and I'm going to pull a negative out, and that's going to change both signs. It'll be negative 3 and positive x. Now I got to do something with that negative. Put it up top. My common denominator then is x minus 3. This is x minus 3 because it's positive x and negative 3. Up top I have negative 2x plus 7x, which is 5x. And there's my answer. And that does not simplify. The third example is like the one I did on the previous page. If a minus 2 is in your denominator, it will be part of the common denominator. If a plus 3 is in your denominator, it will be part of the common denominator. In other words, the least I can do and make these two denominators the same is give this side an a plus 2 and give this side, I have a lot of room here, an a plus 3. And remember, I'm really multiplying by 1. I'm not going to change the value of those fractions. So my common denominator is a minus 2 times a plus 3. Do not remultiply. You can go either order there. Up top, I have to distribute. Take 4a through the parentheses. 4a times a is 4a squared. 4a times 3 will be 12a. And watch out for this sign here. If it's a minus, I have to distribute it. But it's positive 6a times a will be positive 6a squared. And positive 6a times 2 will be positive 12a. Now we'll combine like terms. 4a squared and 6a squared will be 10a squared. 12a plus 12a will be 24a. All over a minus 2 times a plus 3. Look at that numerator. It does factor. You do not need to factor it unless it allows you to cancel. And let's look and see what that would be. Looks like there would be a 2 in both of those and an a. 2a times 5a plus 12. And that wouldn't allow me to cancel anything with the a minus 2 and the a plus 3. So I don't need to do that. This is my answer. A few more examples and we will get to your assignment. Here I need a common denominator for x and y. And again, think of it as the least you can do and make them the same denominator. If there's an x in your denominator, then it is part of the common denominator. This side's going to need an x. If there's a y in your denominator, it's part of the common denominator. This side will need a y. Looks like I have 4y over xy plus 3x over xy. And that is 4y plus 3x over xy. Remember, you can't add those. They're not like terms. In this next example, we have a denominator of a plus 5 and a. I'll always get students that think maybe they could just add 5 to the numerator and denominator. But that does not make an equal fraction. Try it. If you take 1/2 and you add 5 to the top and the bottom, you get 6 over 7. Clearly that is not equal to 1/2. Doesn't work. The way you get a common denominator is by multiplying by 1. If your denominator has an a plus 5 in it, then both of them will have to have an a plus 5 in it. If your denominator has an a, then both fractions will have to have an a in the denominator. The common denominator then is a times a plus 5. We'll multiply, we get 2a. I'm going to write this all as one fraction and skip the step here I did above. Over a times a plus 5. Now it was 2a times a is 2a squared. Be aware that this is a negative 5. Negative 5 times a is negative 5a. And negative 5 times 5 is negative 25. So this would be my answer unless this factored and you could cancel. Well, this is a standard form. See the three pieces that make a standard form? But there's a number in front. And the way you factor when there's a number in front is you multiply the first number and the last number. That's 2 times negative 25, and that's negative 50. And then you're going to ask yourself, are there any factors of negative 50 that add to that middle of negative 5? And the answer is yes. It would be negative 10 and positive 5. So that numerator does factor. I'm going to just factor the numerator by itself. It will be 2a squared and minus 10a plus 5a minus 25. Then these first two have a GCF of 2a times a minus 5. And the last two have a GCF of 5 times a minus 5. Looks like we have a minus 5 times 2a plus 5. Now that would be this numerator right here. Notice that a minus 5 and 2a plus 5 will not cancel with anything below. The only way to cancel a plus 5 is with another a plus 5. And the only way to cancel 2a plus 5 is with another 2a plus 5. What allows you to cancel is anything divided by itself is 1. And 2a plus 5 and a plus 5 are different numbers. This, then, is my answer. This question gets its own page because this takes a little bit of work. To get a common denominator, you need to factor your denominators. Notice that this, factors of 9 that add to 6 are 3 and 3, is x plus 3 times x plus 3. This other one is going to be x plus and x minus, because a negative times a positive is negative 3. And I need factors of 3 that subtract to 2, or 1 and 3. When you place them, they have to add to positive 2, which means it's positive 3 and negative 1. Now I can see what my common denominator is. What's tricky about this one is you have to realize this side has two x plus 3s, x plus 3 quantity squared, which means this other side will have to have two x plus 3s also. So over here, I'm going to multiply by x plus 3 over x plus 3. This denominator has an x minus 1, which means this denominator will also need an x minus 1. You're doing the least you can do and make the denominators the same. Now my common denominator, everything is over x minus 1 times x plus 3 quantity squared. I'm going to distribute here. 5x times x is 5x squared. 5x times 1 is negative 5x. And I'm going to distribute 4x to x plus 3. 4x times x is 4x squared. And 4x times 3 is 12x. Notice this was a plus. I didn't have to worry about distributing the negative. Now I'm going to combine like terms. 5x squared and 4x squared make 9x squared. Negative 5x and positive 12x make positive 7x. And this is all over my denominator of x minus 1 times x plus 3 quantity squared. The numerator has a GCF of x. It'll be x times 9x plus 7. It's not going to cancel with anything below, so I don't need to worry about that. This is my answer. The rest of this video is questions from your assignment. Some of the later ones are a little tricky, so fast forward ahead if you have trouble, but we'll start with question 4. You need a common denominator. Do the least you can do and make the denominators the same. This denominator has an x in it, 8 over x. That means this one will have to have an x in it. I'm going to multiply by x over x. This other denominator has a y, 5 over y, so I'm going to multiply by y over y. Now my denominators are the same. They are xy. I'll go alphabetical there. Up top, I'll have 8y, 8 times y, plus 5x, and I can't add those. They're not like terms. This is my answer. This next one 3 and 6, the common denominator is 18. This side's going to need a 6 to make it 18. And this side's going to need a 3 to make it 18. The left side has a y. The right side will also need a y. The right side has an x in the denominator. The left side will have to have an x in the denominator. So I'll multiply, and I get a common denominator of 18xy. I'll put that below here. 18xy. The numerator will be 12x squared plus 3y squared. And you can't add those. They're not like terms. There's my answer. Question 5, a quick one. This first one, they have a denominator of x, a common denominator of x, and I get 6 over x. The second one has a common denominator of 9x, so I get 11 over 9x. The third one will have a common denominator of 5x. Do the least you can do and make them the same. This side needs a 5. It'll be over 5x then, and I'll have 7 times 5, 35, minus 8 over 5x, which will be 27 over 5x. For the last one, 9 and 2 have a common denominator of 18. That's the least common multiple. This side will need a 9 to make the 2 and 18, and this side will need a 2 to make the 9 and 18. And we have 2 times 6. I'm going to go down below with that. That'll be 12. And this is all over a common denominator of 18x. 12 plus 3 times 9 is 27. I'll simplify that numerator. I get 12 plus 27 is 39 over 18x. Now, if 18 and 39, if they were divisible by a number, I would need to simplify this fraction. 39 is 3 times 13, and 18 is 3 times 6. Because I have times here, that's the only reason this works. If there was addition, it would not work. I can cancel. I can divide both by 3, and I get 13 over 6. My answer then is 13 over 6x. For question 6, we need a common denominator for that 15. That 15 is over 1, and the common denominator is x. It's the least I can do to make them the same. I'll multiply that by x over x. My answer then is 15 minus 15x over x. Always check to see if you can factor cancel. Notice that 15 minus 15x has a GCF of 15. It'd be 15 times 1 minus x. That wouldn't cancel with the x, so there's no reason to factor that numerator. This is your answer. For question 8, they already have a common denominator. The reason this question is here is because you have to understand this needs to be distributed. It's going to be 8x, and distribute that minus, it'll be positive 13x and positive 9. This minus affects both terms in the numerator. It has to be distributed. Simplify that, I get 21x plus 9 over 7x plus 3. Always look to see if you can simplify. 21 and 9 are both divisible by 3. That would be 3 times 7x plus 3 over 7x plus 3. Notice that anything divided by itself is 1, and my answer then is 3. On this assignment, you do not need to worry about restrictions. There would be a restriction here because you know that 7x plus 3 cannot be 0 because you can't divide by 0. Subtract 3 and 7x cannot be negative 3. Divide by 7. And we see that x cannot be negative 3/7. That's our restriction. But we're not asked for that here. Our answer is 3. This one is like the one in the teaching part of the video. These are opposites. See how the 9x is positive, the 9x is negative, the 8 is negative, the 8 is positive. They're exactly the opposite of each other. What I'm going to do then is put one of those denominators in parentheses and pull out a negative and put it up top and change both signs. This is a negative 8 and a positive 9. My common denominator is 9x minus 8. And in the numerator, I have 4 plus negative 6. And 4 plus negative 6 is negative 2. Negative 2 over 9x minus 8. Always check for factor cancel. Can I simplify anything here? No. Question 12, we need a common denominator. I want to do the least I can do and make those denominators the same. I can make this side an x to the fourth if I just multiply by x over x. This becomes 12x plus 5, and my common denominator is x to the fourth. And nothing factors or cancels there. Question 15 is a good example of why you need to factor when you get your common denominator. Both these are the same denominator, and yes, you could go ahead and add the numerators because the denominators are the same. But you're going to notice something when you factor both of these. Let's factor them. Factors of 8 that add to 6 are 2 and 4. X plus 2 times x plus 4. And this is the same here. X plus 2 times x plus 4. Now let's combine those numerators. We have x squared plus 2x. Watch out for the minus. It has to be distributed. Negative x, negative 2 over x plus 2 times x plus 4. Simplify that numerator. It is x squared plus x minus 2 over x plus 2 times x plus 4. Does that numerator factor? Can you cancel anything if it does? So our numerator is a standard form. We know that x times x is x squared. We know it's going to be positive times a negative because we got negative 2 there. Factors of negative 2 that add to positive 1, or because it's a minus 2, you could think of subtract a 1. It's going to be 2 and 1, but you got to make them add to positive 1 in the middle. So positive 2 and negative 1. Now notice we have an x plus 2 in the numerator and the denominator, and anything divided by itself is 1. And yes, we need to realize that x could not be negative 2 because we'd be dividing by 0. That's the restriction. But we're not asked for that here. We're just asked to simplify this. That would be x minus 1 over x plus 4. To get a common denominator, we need to factor our denominators. X squared minus 4 is a difference of squares. This is x plus 18 over x plus 2 times x minus 2. Notice that that right fraction has an x minus 2 in it, which means this left fraction will need an x minus 2 in it. So our common denominator is x plus 2 times x minus 2. We'll distribute the 4 up top. That's 4x minus 8. And watch out for a minus because you need to distribute it, but I don't have a problem here. This will just be plus x plus 18. This will be 5x plus 10 over x plus 2 times x minus 2. Watch for factor cancel. Does this factor? Yeah, it's got a GCF. GCF is the first thing you should always look for. It's 5 times x plus 2. Notice that the numerator and the denominator both have an x plus 2 in them. Be aware that x could not be negative 2 when you cancel that because you'd be dividing by 0. But we're just asked to simplify this. We don't have to worry about restrictions. Looks like the answer is 5 over x minus 2. Question 18. Let's factor that denominator. Factors of 54 that subtract to 3 are 9 and 6. So x plus 9 times x minus 6 minus 4 over x minus 6. They both have an x minus 6 in them. We're good there. But this side is going to need an x plus 9. Since the left fraction has an x plus 9 in the denominator, the right will have to have that too. Now they'll have a common denominator. So we're going to distribute, and watch out, that is a negative 4. Negative 4 times x, negative 4 times 9. So we have x squared plus 4x minus 4x minus 36 all over x plus 9 times x minus 6. This middle simplifies. We get x squared minus 36, which, by the way, is a difference of squares. So it looks like we can factor and cancel. X plus 6 times x minus 6 is x squared minus 36. And anything divided by itself is 1. So the x minus 6's cancel. And we know that x could not be 6. That's our restriction. But our simplified answer is going to be x plus 6 over x plus 9. And our last example, we need to factor the 12 over x squared plus 2x. That's a GCF of x times x plus 2. Notice that this side has an x plus 2, as this does. We're good there. This side has an x. This side here will also need an x. Now the denominators will be the same. Everything will be over x times x plus 2. Up top I have 7x minus 12. Look for any factoring and canceling, and 7x minus 12 doesn't have anything there, so there's nothing I can do. This is my answer.